In the beginning there is only darkness, an endless, silent ocean stretching in all directions, untouched and unknowable. You drift through it as if weightless, carried by an invisible tide that has existed since before time itself learned to move. Nothing interrupts the stillness. No light. No sound. No form. And yet, within this absolute emptiness, a question rises, soft at first, then louder, echoing like a distant storm rolling across the void. What is the most impossible thing in the universe? The question hangs there, suspended between existence and non-existence, daring you to follow it deeper. It pulls at something inside you, curiosity, fear, fascination, urging you to turn your gaze toward the vast cosmic canvas where impossibilities are born. Slowly at first, then suddenly the darkness begins to shimmer. A faint glow pulses, like the heartbeat of a newborn star. Its light spreads through the void, illuminating swirling clouds of dust, fractured shards of forgotten galaxies, and distant cosmic storms tearing open the seams of spacetime. The universe awakens around you. As the light expands, you witness the towering structures of the cosmos, nebulae blooming like cosmic flowers, galaxies spiraling with ancient grace, and gravitational tides sculpting celestial architectures far beyond human imagination. Yet even in this symphony of creation, the question remains. The universe is filled with wonders, but which one of them should be impossible? Which one defies logic so completely that its very existence feels like a violation of reality? Your mind races through possibilities. Is it the birth of the universe itself, a miracle of something emerging from absolute nothingness? Or is it the delicate balance of forces that allow stars to burn without collapsing instantly into oblivion? Perhaps it is life, fragile and improbable, appearing on an insignificant blue world orbiting an average star in a quiet corner of a galaxy among billions. But something is missing. The question presses closer, whispering that the answer is not one of the obvious choices. It suggests that the universe hides a deeper contradiction, one woven into its foundations, invisible yet ever-present, like a shadow cast by something just outside the frame of perception. You feel a subtle chill as if the cosmos itself is aware of being observed, aware of the question that challenges its very integrity. Suddenly the stars around you flicker, dimming as though the universe is inhaling. The silence deepens, heavy and expectant. For a moment, you sense that you stand at the edge of revelation, on the thin boundary between understanding and insanity. The impossible is not merely a rare occurrence. Perhaps it is a fundamental ingredient of existence itself. Images begin to flash before you in rapid succession, each one a fragment of a greater truth. A particle appearing in two places at once. A black hole swallowing information that should never be lost. Time stretching, bending, folding like a sheet of paper in the hands of a cosmic child. Planets forming with perfect symmetry, galaxies colliding in slow, majestic violence, and consciousness emerging from soulless matter like a ghost rising out of stone. Each phenomenon feels impossible in its own way, each one daring you to choose it as the answer. But the question grows sharper, almost accusatory. It isn't asking for a list of anomalies. It is pointing you toward something singular, something that should not only be unlikely, but utterly forbidden. Something that breaks not just scientific laws but the very logic that binds existence together. The cosmic winds shift, and suddenly you are falling, descending through layers of reality, each one peeling away like pages from a forgotten book. You plunge past the known universe, past the observable edge, past the regions where light has never traveled. Here, the fabric of spacetime feels thinner, almost transparent. Through it, you glimpse shapes without form and rules without meaning, drifting like ghosts in a place where existence hasn't decided what it wants to be yet. A faint sound rises beneath you, like a distant crack. It grows louder, reverberating through the void until it becomes clear. The universe is straining. Something within its structure is under tension, stretched beyond what should be possible. As if reality itself is trying to hold together a truth too heavy for its foundations. You reach out instinctively though there is nothing to touch. Fear mixes with awe. The universe is not a serene masterpiece, it is a precarious miracle, teetering between order and chaos. You feel the weight of the impossible pressing against the thin walls of reality, threatening to burst through. And in this moment the question transforms. It is no longer a whisper. It is a challenge. What if the most impossible thing in the universe is the universe itself? The darkness slowly returns, swallowing the stars, the light, the visions. But the question remains, burning in the void like a hidden flame. An invitation. A warning. A mystery waiting to be unraveled as the journey begins. The universe has rules, clear, elegant, and uncompromising. They are the invisible laws that govern every star, every atom, every heartbeat. They shape the path of light, dictate the dance of galaxies, and whisper instructions to particles so small they barely exist. And yet, scattered across the cosmos are moments, rare, unsettling, unforgettable, when the universe seems to hesitate, slip, or outright rebel against the very laws it created. It begins quietly, with stories whispered among scientists who stumble upon results that make no sense. A detector registers a particle where no particle should be. A star flickers in a pattern that defies every known model. A magnetic field oscillates in ways no equation can capture. These are not illusions or errors. They are hints, subtle cracks in the cosmic blueprint, suggesting that reality occasionally breaks character. Imagine a scientist in a dim laboratory at 3 a.m., illuminated only by the pale glow of monitors. They stare at a graph that shows a spike, an impossible spike, one that should not exist according to any known theory. Their pulse quickens. They rerun the experiment. The spike returns. Again. And again. With each repetition it becomes clearer. They have discovered a violation, a fingerprint of the universe doing something it is not supposed to do. History is full of such moments. A compass needle refusing to point north in the presence of a mysterious stone. Mercury orbiting the sun in a way that mocked Newton's perfect equations. Light bending, splitting, shifting as though space itself were twisting. Every scientific revolution began with the same spark. Something impossible forcing humanity to rewrite its understanding of the cosmos. But not all impossibilities lead to triumph. Some linger in the shadows, unexplained, like flaws in a massive cosmic engine too complex for human minds to dismantle. Consider the particle that appears faster than light, even though relativity forbids it. Or the star that seems older than the universe. Or the ghostly neutrinos that slip through entire planets as if matter were only a suggestion. Each discovery is like a message, hinting that the universe's rulebook might be less rigid, and far stranger, than we imagine. Look deeper and the contradictions grow sharper. There are regions of space where gravity behaves as though something enormous is there, yet nothing can be seen. An invisible presence pulling stars into orbits they shouldn't have. Dark matter they call it because naming the unknown makes it feel less terrifying. But the truth remains, the universe is shaped by something we cannot detect, measure, or comprehend. It violates every instinct we have about what exists. Then there are particles that wink in and out of being, appearing for a fraction of a moment before vanishing back into nothingness. They borrow energy from the void, break the rules of conservation, and repay the debt so quickly the universe chooses to look the other way. These virtual particles shouldn't exist, yet they constantly surge beneath the surface of reality like forbidden waves. And what of the universe's expansion, accelerating, racing outward faster and faster? According to everything we know, the expansion should be slowing, dragged down by gravity. Instead, it is speeding up, propelled by an unseen force scientists reluctantly named dark energy. A placeholder term. A quiet admission, we have no idea what is pushing the universe apart. Even time itself, the most trusted companion of existence, sometimes breaks the rules. In certain extreme environments, like the edge of black holes or the violent birth of the cosmos, time stretches and twists until seconds become centuries and cause no longer leads cleanly to effect. The chain of reality buckles, and the rules we depend on melt into chaos. For every law humanity discovers, the universe presents a counterexample, a moment where the line between possible and impossible blurs. These anomalies are not accidents, they are signatures. Signs that the universe may contain layers of truth hidden behind the thin veil of what seems logical. The strange part is not that such impossibilities exist. The strange part is how consistently they appear, small glitches in the grand machinery, reminding us that the cosmos may be far more flexible, unpredictable, and alive than any model suggests. Perhaps the laws of physics are not fixed but adaptive. Perhaps they are not universal but local. Or perhaps they are merely approximations of deeper rules we cannot yet see. The emotional tension rises when you consider how fragile humanity's understanding truly is. Every equation feels suddenly temporary. Every theory vulnerable. At any moment, the universe might reveal another contradiction, another anomaly that shatters a century of certainty. It forces a confrontation with a frightening possibility, that our understanding of reality is built on sand shifting beneath our feet. Imagine walking through a grand cathedral of stars, each one governed by precise mathematical harmonies. Now imagine hearing a single note go out of tune. Then another. Then another. Soon, the entire cosmic symphony warps, revealing that the sheet music we believed in was only a small fragment of a far more complex composition. A composition that changes, mutates, and evolves as if it has a consciousness of its own. This is where awe blends with fear. Because if the universe can break its own rules, then nothing, absolutely nothing, is guaranteed. The constants we trust, the forces that bind atoms, the patterns that shape galaxies, any of them could shift. Subtly, suddenly, catastrophically. And if they do, existence as we know it could unravel with silent precision. Yet within this uncertainty lies the spark of discovery. The impossible forces scientists to look deeper, to question assumptions, to peel back the layers of reality with trembling hands. Every impossibility is an invitation to expand the boundaries of knowledge. Every anomaly is a doorway to a new world. We are propelled forward by contradictions, compelled by them, transformed by them. Still, one question lingers in the quiet space between discoveries. If the universe breaks its own rules, then what is the original rulebook? What is the deeper order beneath the visible laws? And if there is something more fundamental hidden below the surface of reality, is it stable, or is it breaking too? The tension hangs like a storm cloud. Somewhere out there, the most impossible phenomenon of all waits, untouched and unresolved. The cracks in the universe's logic are only hints, shadows pointing toward a greater impossibility that has yet to reveal itself. There is a limit to how far the human mind can reach, a silent boundary drawn not on maps of stars or galaxies but within the folds of our own biology. We like to imagine ourselves as explorers standing at the edge of infinite knowledge, but the truth is more fragile, more haunting. Humanity exists inside a narrow window of perception, able to see only a sliver of the electromagnetic spectrum, hear only a small range of vibrations, and understand only what our brains are physically capable of processing. The rest of reality lies hidden, like vast continents shrouded in permanent night. Imagine standing at the shore of a cosmic ocean. You can hear the waves, smell the salt, feel the mist on your skin, but you cannot see beyond the first line of surf. You know there is more, endless more, but your senses refuse to reveal it. This is the position humanity occupies in the universe, aware of our limitations yet trembling with curiosity, forever reaching but never touching the full truth. The greatest telescopes humanity has built, massive machines of glass, metal, and algorithms, stretch their gaze toward the farthest corners of the cosmos. They pierce clouds of dust, capture photons that have traveled billions of years, and reveal structures so enormous they make the Milky Way look like a mere grain of dust. Yet even these powerful instruments are blind to most of what exists. 95% of the universe is invisible to us. Dark matter, dark energy, unseen forces sculpting galaxies and steering cosmic evolution. We detect their effects like footprints in the sand, but we cannot observe the beings that left them. Even within the Earth's atmosphere, there are forms of reality humans simply cannot grasp without instruments. Magnetic fields flicker and warp around us. Particles rain down from distant supernovas, passing through our bodies by the trillions each second. Invisible waves ripple through the air, carrying information from stars, machines, and perhaps even unknown sources we have yet to identify. Our senses provide only the faintest hints of the true complexity surrounding us. But the limitation is not just sensory, it is cognitive. The human brain evolved for survival, not for comprehending the full architecture of the universe. Our ancestors needed to detect predators in bushes, not understand the curvature of spacetime or the probability flows of quantum fields. And so, even today, our neural circuits struggle when confronted with concepts that have no counterpart in daily life. Infinity, singularity, nonlinear time, higher dimensions. We translate these ideas into simplified metaphors, rubber sheets, stretched fabrics, ripples and ponds, because the actual physics is too alien for our minds to grasp directly. This cognitive boundary becomes even clearer inside the labs where scientists confront the bleeding edge of knowledge. A physicist might spend decades studying equations that hint at strange truths. Particles that lack definite positions, energy that appears from nothing, time that behaves inconsistently. They can write the equations, manipulate them, extract predictions from them, but understanding them in the intuitive sense? That is something else entirely. Many scientists admit privately that they do not understand quantum mechanics. They simply know how to work with it. It is here, in this struggle between comprehension and calculation, that the emotional weight of the unknown becomes overwhelming. We are creatures designed to seek patterns, yet we face a universe full of chaos pretending to be order. We try to impose structure on something that feels fundamentally structureless. We build models that explain a fraction of reality and hope that fraction is enough to survive the next revelation. Humanity stands at the edge of understanding, staring into a darkness filled with unanswered questions. How does consciousness arise from matter? What existed before the Big Bang? Is time a fundamental property or merely a flawed perception? Where does the boundary between the possible and impossible truly lie? These questions linger like ghosts, haunting every attempt to push the frontier forward. There are moments when our exploration feels almost heroic. A probe slingshots around a distant planet, sending back images of alien storms and frozen oceans. A satellite detects gravitational waves, vibrations from cataclysmic events billions of years old. A particle collider glimpses a new particle that survived only for a trillionth of a second. Each success feels like lifting a veil, revealing a tiny corner of the universe that had remained hidden for eons. But with each answer comes a deeper mystery. For every rule discovered, a contradiction emerges. Every theory leaves questions unresolved. The horizon of knowledge expands, but the distance to the ultimate truth remains unchanged. It is like climbing a mountain shrouded in fog. Each step reveals new peaks rising endlessly ahead. This emotional tension, between advancement and uncertainty, drives some thinkers to wonder whether there is a hard limit to what humans can ever understand. Maybe the universe contains truths that no biological mind can grasp, concepts too vast or too alien for neurons to encode. Perhaps there are forms of logic beyond human logic, dimensions beyond human geometry, or structures beyond human mathematics. If such truths exist, they would remain forever outside our reach, no matter how advanced our technology becomes. Yet this is not a cause for despair. It is an invitation, a challenge, a reminder that mystery is the fuel of progress, that impossibility is the engine driving human curiosity. Without the unknown, the mind would stagnate. Without boundaries, we would never push beyond them. Still, the question remains, what lies beyond the limits of human understanding? The answer might be as simple as forces we cannot detect or as unimaginable as structures of reality that require entirely new forms of consciousness to perceive. There may be civilizations, long vanished or still thriving, whose minds evolved in ways ours cannot. They may see the universe not as chaos but as clarity, not as confusion but as harmony. To them, the cosmic mysteries that terrify us might be as ordinary as sunlight. And if such beings exist, or ever existed, then we are not standing at the edge of understanding. We are standing at the very beginning of it. The universe stretches beyond the reach of our eyes, beyond the capacity of our instruments, and beyond the architecture of our minds. It is a vast labyrinth of forces, dimensions, and truths that challenge everything we believe about existence. The closer we move toward the limits of perception and knowledge, the more the universe seems to blur, warp, and whisper back at us. But somewhere past these limits, hidden by the fog of the unknown, lies a deeper impossibility, one that shapes everything we see yet remains invisible. And as we push against the edge of understanding, that impossibility waits, silent and patient, for us to finally notice it. There is a moment, quiet and almost sacred, when a person stares into the night sky and suddenly feels the weight of a question humanity has carried since the dawn of consciousness. Why does anything exist at all? The stars shimmer like distant embers scattered across an infinite canvas, each one burning with its own impossible story. But beneath their beauty lies a deeper, darker mystery, one so profound that even the greatest minds in history trembled when confronting it. The universe should not be here. Space, time, matter, energy, consciousness, none of it should exist. And yet it does, shimmering defiantly against the backdrop of absolute nothingness. To understand the impossibility, imagine true nothingness. Not empty space, not a dark vacuum, not silence or stillness. Those things are still something. True nothingness is the absence of existence itself, a state with no dimensions, no laws, no potential, no future or past. No canvas, no stage, no actors, and certainly no story. It is a concept so alien that the human mind can barely grasp it. Every thought we have is made of something, every perception shaped by existence. So when we try to picture nothingness, our minds fail, offering only dark empty space, which is still a form of existence. Yet according to our best reasoning, nothingness should be the default. Existence requires explanation. Non-existence does not. Nothingness needs no cause, no origin, no laws, it simply is, or should be. And that is where the impossible begins. At some point, for reasons no equation can fully describe, something ruptured that perfect absence. A spark, not in space but of space. Not an explosion because there was no environment to explode into, but a sudden flowering of existence where none should have been. This event, the Big Bang, marks the single greatest violation of intuition and logic humanity has ever encountered. From a state of absolute nothing, a universe emerged filled with energy, particles, forces, and the seeds of galaxies. It is the ultimate magic trick, the most baffling transition imaginable. Scientists propose theories to explain how something could arise from nothing. Quantum fluctuations, vacuum instabilities, symmetry breakings. But every explanation relies on something already existing. A field, a law, a possibility. None address the raw paradox. Why were any of these things there to begin with? Where did the rules come from that allowed the universe to burst into being? If nothing truly existed before the cosmos, the very concept of allowing or causing becomes meaningless. Philosophers wrestle with this problem too. Some argue that existence is a fundamental brute fact. Others propose that nothingness is unstable, naturally collapsing into existence like a vacuum imploding. Some suggest that asking why the universe exists is like asking what color the number 7 is, a flawed question. Yet none of these explanations feel satisfying. The emotional unease remains. Something exists, and it absolutely should not. Consider how unlikely our universe is, not just its existence but its structure. The physical constants that govern reality are tuned to nearly impossible precision. If gravity were slightly weaker or stronger, stars would never form. If the charge of the electron differed by a fraction, matter itself would fall apart. If the expansion rate of the universe were even minutely different, space would either collapse into a cosmic grave or rip itself apart before atoms formed. The universe balances on a razor's edge, a narrow window where existence is not only possible but inevitable. And yet, why should the universe exist in any window at all? Even the emergence of life and consciousness adds layers to the impossibility. The atoms in your body were forged in ancient stars, themselves born from the delicate collapse of massive clouds sculpted by gravity. The molecular dances that led to life are so improbable that in a universe filled with trillions of planets, we have yet to find another inhabited world. And consciousness, the shimmering awareness inside your mind, is so unlikely that its very presence feels like a miracle unfolding in real time. Every breath you take, every thought that sparks in your brain, every moment you observe the world around you, these are acts of defiance against the void. You are a creature made of stardust, standing on a tiny planet, in a vast universe, asking questions that the universe itself may not be prepared to answer. But the haunting truth is this: even if we map every particle, decode every law, simulate every cosmic event, we may never escape the central paradox. Knowledge can explain the mechanics of existence but not the reason for existence. Mechanisms describe how things happen. Reasons explain why they happen at all. And the universe's reason remains hidden. Maybe existence is the ultimate mystery, not because it is complex but because it is unnecessary. As you gaze into the cosmic darkness, the question deepens, becoming more urgent, more unsettling. Why is there something when there could so easily have been nothing? What force or principle or accident broke the perfect silence of non-existence? And if the universe emerged from nothing once, could it happen again? Or has it happened countless times, scattered across realities we will never see? These questions echo into the void, unanswered and perhaps unanswerable. And yet, they pull you forward, guiding you deeper into the cosmic mystery. For somewhere within this tension, between existence and the possibility of nothingness, lies one of the universe's greatest impossibilities, waiting to be uncovered. Reality feels solid, predictable, familiar. You wake up, open your eyes, and trust that the world you see is the world that truly exists. The floor beneath your feet feels stable. The sky looks blue. Objects stay where you leave them. Time moves forward. These experiences form the foundation of your life, the silent assumptions that make the world seem understandable. But the deeper science looks beneath the surface, the more this familiar reality dissolves into something fragile, something deceptive, something that behaves nothing like the world we think we inhabit. Imagine standing in a vast hall of mirrors where every reflection looks real, yet none of them shows the full picture. The universe is that hall. Reality is not a window, it is a filter. Everything you experience is a processed version of the world, shaped by senses that evolved for survival, not truth. Your brain transforms raw chaos into comforting order, editing, simplifying, and even inventing details so that existence feels coherent. What you see is not the universe as it is, but the universe as your biology allows you to perceive it. Consider color. You may think color is a property of objects, but it isn't. Color does not exist out there. It is an illusion generated by your brain interpreting different wavelengths of light. The universe itself is nearly colorless. Or consider solidity. The chair you sit on feels firm, yet the atoms inside it are mostly empty space, their electrons never truly touching yours. What you feel is electromagnetic repulsion, a force field masquerading as solidity. Reality is built on interactions, not contact. Even time, the most reliable sensation you have, is an illusion of perception. You feel time flowing like a river, but physics shows it does not flow at all. Past, present, and future exist simultaneously in a static block of spacetime. Your consciousness simply moves through it like a spotlight sweeping across a frozen landscape. The now you treasure exists only in the theater of your mind. But these are merely the cracks in the illusion. At the quantum level, reality breaks apart entirely. Particles do not behave like solid objects. They appear as probabilities, ghost-like waves of potential that collapse into definite states only when observed. Before you look at an electron, it is not in one place. It exists in every possible place. The world is not made of things. It is made of possibilities waiting to be chosen by observation. Your act of measuring reality helps create it. This leads to a chilling possibility. The world you see exists partly because you observe it. You are not just a spectator, you are a participant in shaping what becomes real. Consciousness and reality are entwined in ways we barely understand. Some physicists argue that reality doesn't fully exist until measured. Others believe the universe might constantly render only the parts being observed, much like a simulation. Even space itself is not as reliable as it appears. Quantum fields ripple beneath the fabric of space-time, flickering with unpredictable fluctuations. Virtual particles appear and vanish, violating classical logic. Space bends and curves under the influence of mass, creating distortions that make objects move as if unseen hands were pushing them. Gravity, in Einstein's view, is not a force but the shape of reality itself. And then there is perception, the fragile lens through which all this complexity is interpreted. More than 99% of the information entering your senses is discarded before it reaches awareness. Your brain constructs a simplified model of the world, filled with shortcuts, guesses, and illusions that make life manageable. You see patterns where none exist. You fill in missing pieces without noticing. Your memory rewrites itself constantly, blending truth with imagination until the line between them dissolves. In this sense, you never interact with reality directly. You interact with a simulation built inside your skull. A model. A representation. A story your brain tells you, one that must feel real for you to function, but has little obligation to match the actual universe. This raises a disturbing question. If the world we perceive is an illusion shaped by senses, biology, and consciousness, then what is the true nature of reality? Is it a sea of vibrating quantum fields? A mathematical structure? A holographic projection from a deeper dimension? A fluid, shifting system that changes based on observation? Or something stranger still, beyond the reach of any human concept? The deeper one looks, the more reality behaves like a stage play where the props dissolve when not in use. The world is stable only when observed. Solid only when touched. Predictable only at human scales. Beneath that lies a chaotic, dreamlike foundation where certainty evaporates. This is where wonder and fear collide. Because if reality is an illusion, or at least a filtered, distorted version of something far stranger, then everything you know becomes just a suggestion. Your identity, your memories, your perception of space and time, all potentially fragile constructs floating atop a deeper truth. And somewhere beneath these illusions, behind the shifting patterns and invisible rules, the universe hides something far more impossible. Something that bends not only our understanding of physics but our understanding of existence itself. A truth waiting in the shadows of reality, patiently revealing itself, layer by layer. Quantum mechanics is not just strange, it is the single greatest insult to logic the universe has ever delivered. The closer you move toward the quantum world, the more every rule you trust evaporates. Objects stop behaving like objects. Cause and effect unravel. Certainty becomes impossible. And the universe reveals a layer of reality so bizarre, so contradictory, so utterly incompatible with human intuition that it feels like a cosmic joke played on the mind of humanity. This is the realm where logic fails. This is the domain of impossibility. Imagine shrinking yourself far smaller than atoms, smaller than electrons, smaller than quarks, until you enter a realm where the ordinary laws of physics crumble like dust. Here, particles are not tiny balls or specks. They are waves of possibility, smeared across space, existing in many states at once. They are everywhere and nowhere. Present and absent. Real and not real. The quantum world does not care about classical reasoning. It listens only to its own impossible laws. Begin with the simplest idea, a particle's position. In the quantum world, nothing has a definite position unless it is observed. Before measurement, an electron isn't in one place. It is in every possible place simultaneously. It exists as a cloud of probabilities, a ghostly wave that spreads across space. Only when you look does the wave collapse into a specific point. The universe seems to wait for an observer before deciding what is real. This alone bends the mind. But the impossibilities go much deeper. Take the famous double-slit experiment. Fire one electron at a barrier with two openings, and something magical happens. If you do not observe which slit it goes through, the electron behaves like a wave and passes through both slits at the same time. It interferes with itself, creating a pattern on the screen that should be impossible for a single particle. But if you watch the electron, if you simply observe its path, it suddenly behaves like a particle again, choosing one slit and obeying classical rules. Observation changes reality. The universe behaves differently depending on whether someone is watching. This eerie dependency suggests a connection between consciousness and the physical world that science cannot fully explain. It is as if the universe hides its true nature when unobserved, adopting a simpler, more comprehensible form only when forced to reveal itself. Now consider quantum entanglement, Einstein's spooky action at a distance. Two particles become linked so deeply that measuring one instantly determines the state of the other, even if they are separated by galaxies. Information seems to travel faster than light, violating relativity, yet no physical signal passes between them. Space and time appear irrelevant. Distance becomes meaningless. In this entangled state, reality behaves like a coherent whole rather than separate pieces. It suggests that the universe is not a collection of independent particles, but a deeply interconnected system where separation is an illusion created by our limited perception. Then there is superposition, the idea that quantum objects can be in multiple states simultaneously. An electron can spin up and spin down at the same time. A photon can move left and right. A particle can be alive and dead in the realm of quantum information. This is not metaphor. This is measurable, tested, verified behavior. Superposition is the engine of quantum computing, where qubits exploit the impossible to perform calculations classical computers could never achieve. But the impossibility grows stranger still. Quantum tunneling defies every classical law. Particles pass through solid barriers without enough energy to cross them, as if slipping through walls by ignoring the universe's restrictions. This phenomenon powers nuclear fusion inside stars. Without this violation of logic, the sun would go dark. Reality depends on impossibility. And beneath even these paradoxical behaviors lies another layer of unsettling truth: quantum fields. These fields fill all of space, vibrating constantly. Particles are just localized excitations of these fields, waves rising out of a deeper ocean. But the fields themselves fluctuate endlessly. They produce virtual particles that pop in and out of existence in empty space, breaking conservation laws temporarily but consistently enough to be detectable. The vacuum is not empty at all. It is a restless, boiling sea of energy. Here the universe is not stable. It is not calm. It is not logical. It is a churning storm of possibilities and probabilities, guided by mathematical rules so strange that even the physicists who use them admit they do not understand them, only that they work. This raises a dangerous question. If the fundamental layer of reality operates through impossibility, then is classical reality just a convenient illusion? A simplified version of the universe rendered for creatures incapable of understanding the truth? Quantum mechanics suggests that the laws of nature are not just counterintuitive, they are deeply contradictory. A particle can be in two places at once. A measurement in one location can affect another location instantly. Probability replaces certainty. Events do not have definite outcomes until observation locks them into place. Even causality, one of the foundations of human reasoning, breaks down in certain quantum systems where effects can appear before causes. Every contradiction forces us to confront a chilling realization: the universe is not built on logic. Logic is something humans invented to make sense of patterns. But the universe itself does not obey human logic. It obeys quantum logic, a system so alien that even naming it logic feels misleading. And perhaps most unsettling of all, the quantum world remains completely hidden beneath the surface of everyday life. You never see these contradictions directly. You perceive a stable, predictable world because quantum uncertainty averages out at large scales. The impossibilities remain buried beneath layers of emergent order, like a violent ocean hidden beneath a calm surface. Yet that calm surface hides the deepest mystery: A universe whose foundations are built not on certainty but on impossibility. And somewhere within this chaotic, contradictory realm lies a truth so strange, so defiant of understanding, that even quantum mechanics struggles to describe it. A truth that may be the most impossible phenomenon in the cosmos, still waiting to be revealed. The pursuit of absolute zero is one of humanity's most haunting scientific odysseys, a quest to touch a temperature that the universe itself seems to guard with relentless determination. Absolute zero, the coldest state imaginable, is not just very cold. It is a boundary written into the laws of physics, a place where motion ceases, energy fades, and atoms stand so still they almost escape existence. It is the theoretical point where the universe goes silent. And yet, as we chase this impossible limit, we discover secrets that feel as though nature is whispering warnings in the frost. Imagine a laboratory bathed in pale blue light, humming with the low vibration of powerful machines. Inside a chamber protected by layers of vacuum and magnetic fields, scientists hover over instruments capable of cooling matter to temperatures that would freeze stars. This is no ordinary cold. This is cold so deep it slows the jittering dance of atoms until they move slower than glaciers, slower than drifting galaxies, slower than time itself seems to pass. To understand the impossibility of absolute zero, you must understand what temperature truly is. Heat is motion. Every object, no matter how still it seems, is a storm of atoms vibrating, colliding, twisting with frantic energy. Even in the vacuum of space, where the temperature drops near 2.7 Kelvin, the faint afterglow of the Big Bang keeps particles trembling. Absolute zero, at 0 Kelvin, is the dreamlike point where that motion disappears entirely. But nature resists this silence. The closer you try to reach it, the harder it becomes. In the 19th century, scientists began to realize that as an object cools, removing heat becomes progressively more difficult. Temperatures drop quickly at first, then slower still. Like chasing a mirage in the desert, absolute zero recedes just as your fingers reach for it. Even the most advanced techniques, laser cooling, evaporative cooling, magnetic trapping, can only bring atoms infinitesimally close. Never touching. Never crossing. Yet the approach toward absolute zero reveals wonders no one expected. As atoms slow, they begin to act less like individual particles and more like a single unified entity. At these unimaginably low temperatures, matter undergoes transformations that defy intuition. Gases condense into strange quantum states. Particles merge into waves. Superfluids form, liquids that flow without resistance, climbing walls, escaping containers, behaving like something out of a dream. Superconductors appear, materials through which electricity travels with perfect efficiency, ignoring the usual rules of resistance. Near absolute zero, matter becomes perfect. Imagine a droplet of superfluid helium. Touch it and it slips away without friction. Set it spinning and it will rotate forever, ignoring gravity, ignoring time. Its motion seems eternal, untouched by decay. It is as if you are witnessing a small rebellion against the universe's most fundamental law, entropy, the natural tendency toward disorder. But as you push further, seeking even colder temperatures, the universe pushes back. Quantum uncertainty becomes overwhelming near absolute zero. Even as motion slows, particles cannot fully stop. They jitter with an irreducible energy, something physicists call zero-point energy. This tiny vibration is not optional. It is mandatory. A particle without zero-point energy would have a precise position and momentum, something the laws of physics absolutely forbid. Zero-point energy is nature's way of preventing absolute zero. It is the universe saying, you may approach the boundary but you will never cross it. Still, humanity reaches closer every decade. We have cooled atoms to within billionths of a degree above absolute zero. In these conditions, a strange phenomenon emerges, Bose-Einstein condensates, where thousands of atoms behave as one giant superatom, perfectly synchronized as though they share a single consciousness. The sight of such a condensate drifting gently under a microscope feels less like science and more like watching a living dream. But the pursuit raises darker questions. What would the universe be like at absolute zero? A cosmos perfectly still, perfectly silent, frozen at the level of reality itself. Would time exist? Would space change? Would matter hold its structure, or would all forms dissolve into a quantum haze? If motion defines energy and energy defines existence, then a universe at absolute zero might be a universe teetering on the edge of nothingness. Some physicists propose that hidden beneath the temperature barrier lies a new kind of reality, one where quantum vacuums behave differently, where information crystallizes into stable patterns, where the laws of physics shift into forms we have never encountered. Others warn that reaching absolute zero might reveal vulnerabilities in the fabric of reality, exposing cracks in the cosmic machinery. A chilling thought remains. What if the reason absolute zero is impossible is that the universe is afraid of what lies beyond it? Because if absolute zero could be reached, even for an instant, it might unravel phenomena we take for granted. It could freeze the quantum fields that define matter. Stop fluctuations necessary for existence. Collapse the very structure of spacetime. The barrier might not be a limit of technology, but a safeguard woven into the universe to prevent catastrophic stillness. As scientists continue the pursuit, they walk the razor's edge between discovery and forbidden territory. Every fraction of a degree closer reveals something new, something beautiful, something terrifying. But the boundary remains. Absolute zero sits at the heart of physics like an immovable stone, daring us to question why it exists. And in that icy silence, beneath the shifting shadows of quantum states and the slow heartbeat of frozen atoms, lies a deeper impossibility waiting to be uncovered, one colder than any temperature, one hidden in the fabric of existence itself. There is a speed woven into the fabric of the universe, a cosmic limit so absolute that nothing, no particle, no signal, no vibration of space, can surpass it. This speed is the speed of light, 299,792 kilometers per second, an almost unfathomable velocity that acts as the ultimate governor of reality. To human intuition, speed feels like something that can always be increased with enough force, enough power, enough determination. But the universe disagrees. It enforces its speed limit with terrifying precision, shaping the evolution of galaxies, the aging of stars, the behavior of time itself. Yet behind this cosmic boundary lies a mystery so deep that breaking the limit might not just be impossible, it might unravel the entire structure of existence. Imagine standing at the edge of a vast interstellar desert, looking out at stars separated by unimaginable distances. Even if you traveled at the fastest speed physically allowed, it would take years, decades, to cross the cold emptiness between them. Light, the fastest phenomenon in existence, needs over 4 years to reach us from the nearest star. From the center of our galaxy? 26,000 years. From distant galaxies? Millions, billions. The speed of light isn't just fast, it defines the scale of cosmic loneliness. But why does such a limit exist at all? Why can nothing outrun light? The answer begins with Einstein's revelation, that the speed of light is not just a speed, it is a cosmic constant that spacetime uses to measure everything. It's the conversion rate between distance and time. It's the heartbeat of the universe. Go faster than light and spacetime can no longer keep track of cause and effect. Events could happen out of order. Consequences could occur before their causes. Reality would fall apart. Yet this limit creates terrifying consequences for travelers. The faster you move, the more the universe punishes you. Time slows down. Mass increases. Energy demands skyrocket to infinity. A spaceship trying to reach light speed would require infinite energy, an impossible price. Even the universe's fastest particles like neutrinos or cosmic rays will never reach that final threshold. It is a wall no one can climb. But the impossibilities grow stranger. Light doesn't experience time. A photon leaving a distant galaxy billions of years ago does not feel those billions of years. From its own perspective, it travels instantaneously. The beginning and end of its journey are the same moment. Light moves through space but does not age. It is frozen in a timeless state, existing at the boundary between the possible and the impossible. In some sense, light does not travel. It simply exists across its path. This cracks open a disturbing question. What would it mean to exceed light speed? To move faster than something that experiences no time? Some theoretical particles, called tachyons, are proposed to always move faster than light. But if tachyons exist, they introduce catastrophic paradoxes. They could send information back in time. They could violate causality. They could unravel the logic of the universe. Most physicists believe tachyons are mathematical ghosts, ideas that hint at deeper truths but cannot exist in reality. Yet nature reveals hints that something may already be exceeding this limit, quietly, invisibly. Consider dark energy, the mysterious force accelerating the expansion of the universe. Galaxies are moving away from us faster than the speed of light, not because they are traveling through space faster than photons can move, but because space itself is stretching. The expansion of spacetime is not bound by light speed. Entire galaxies slip beyond our observable universe, vanishing into darkness, not because they outran us, but because spacetime carried them beyond the horizon. This loophole suggests a profound truth. Nothing can move faster than light through space, but space itself can move faster than light. Then there are quantum phenomena that seem to ignore the limit entirely. Entangled particles share information instantly across vast distances, as if the universe is bypassing its own restrictions. Quantum tunneling allows particles to appear on the other side of barriers without crossing through them, reaching a destination faster than any classical path would allow. And deeper still are theoretical constructs like wormholes, tunnels through spacetime that could, in principle, let something arrive before it leaves. These are mathematically possible but require exotic forms of energy and matter that may not exist at all. Yet even these strange exceptions only highlight the deeper mystery. Why does the speed of light exist as the limit? Some believe it is simply geometry, the shape of spacetime demands it. Others think it is an emergent property of the quantum vacuum. Some propose that the speed of light is a byproduct of deeper rules we have not discovered yet. But there is a darker, more unsettling possibility. The speed limit exists to protect reality, to prevent contradictions, to enforce a sequence to existence. If information could move faster than light, the universe could become inconsistent, fragmented, or logically impossible. The limit may be the universe's firewall, its way of safeguarding causality. And yet, what if something has already broken the rule? What if a deeper layer of reality operates beyond light speed, hidden from us by the limitations of our perception? Some theories suggest that the deepest processes of the universe, like the machinery behind quantum entanglement or the fabric of the vacuum, operate outside spacetime altogether. If so, the ultimate question becomes unavoidable. Is the speed of light truly a fundamental limit, or is it one of many illusions created by a universe that hides its true nature behind boundaries we are not evolved to see? Somewhere beyond this cosmic speed limit, beyond the shimmering edge of what is allowed, may lie the most impossible truth of all. A truth not bound by light, time, or causality. A truth waiting in the dark, silent corridors of spacetime, where the impossible becomes the framework of reality itself. Humanity has always been haunted by two opposing visions of the future. One filled with eternal life, endless possibility, and boundless evolution, and the other ending in cold, inevitable darkness. These two destinies stand in perfect contrast, the dream of immortality versus the reality of heat death. One is a fantasy where consciousness transcends the limits of flesh and time. The other is a cosmic verdict written into the physics of the universe. And between them lies the silent question that has troubled philosophers and scientists for centuries. Can meaning survive in a universe destined to die? Begin with the dream, the ancient human yearning for immortality. For thousands of years, civilizations imagined ways to escape death. Through myths of gods and spirits. Through alchemy. Through religion. Through the idea that the soul continues even as the body decays. Today the quest has evolved, clothed in the language of science. Genetic rejuvenation. Advanced medicine. Artificial intelligence. Mind uploading. Humanity imagines a future where consciousness becomes permanent, where aging is reversed, where death becomes optional. Picture a scientist in a quiet laboratory, illuminated by the pale glow of data streams. They are mapping the human brain cell by cell, synapse by synapse. Somewhere in those tangled neural threads lies memory, identity, emotion, the fragile miracle of consciousness. If it could be preserved, replicated, sustained indefinitely, would that not be a kind of immortality? Would humans live forever in biological bodies? Digital worlds? Machines that outlast stars? But even if humanity defeats biological death, what then? What would immortality mean in a universe governed by entropy? Entropy, the cold law that no one can outrun. The universe always moves toward disorder. Energy spreads. Heat dissipates. Stars consume their fuel. Galaxies drift apart. Over billions, trillions of years, the cosmos grows colder, emptier, quieter. Eventually all stars die. Black holes evaporate. Matter decays. Motion stops. The universe approaches a final state, a thin, dark smear of particles drifting in near-perfect stillness. No light. No heat. No complexity. No life. This fate is known as the heat death of the universe, a future so bleak it almost feels like a cosmic punishment. It is not dramatic. It is not explosive. It is a long, slow fading, the universe sighing into eternal emptiness. Set the two visions side by side and their contrast becomes heartbreaking. In the dream of immortality, life becomes infinite. Minds explore for eternity. Sentience spreads across galaxies. New forms of consciousness evolve. civilization becomes a cosmic force. In the reality of heat death, everything ends. The stars that once inspired myths burn out. The galaxies that once shone with brilliance go dark. Even the atoms that form our bodies dissolve into nothingness. Immortality becomes a cruel joke. What is eternal life worth if the universe itself does not survive? This contradiction forces a deeper question. Can immortality truly exist in a universe destined for entropy? Some philosophers argue that meaning derives from finitude, that mortality gives life urgency and depth. Others believe existence is meaningful only if it continues. Without continuity, the universe becomes a brief accident destined to vanish. Human dreams of immortality contrast sharply with the universe's cold indifference. But the story grows more complex. There are scientific theories that challenge heat death. Some propose that quantum fluctuations might create new universes even as this one dies. Others suggest that consciousness itself might find a loophole, migrating into new dimensions or new realities. Perhaps advanced civilizations could harness the last shrinking sparks of energy, stretching out life far beyond what seems possible. Perhaps the universe will not end in darkness, but in transformation. Still, the most unsettling possibility remains. Immortality might be impossible not because of biology, but because the universe is temporary. The cosmos itself has an expiration date. Think of a candle burning in a cathedral. Its flame dances, warm and bright, illuminating ancient stone walls. Human life is that flame. The universe is the cathedral. Even if you protect the flame from wind and time, the air inside the building will eventually run out. The environment that sustains life has its own limits. And yet, despite this cosmic doom, humanity continues to strive for meaning. We love, we create art, we build civilizations, we imagine futures that stretch beyond stars. It is a rebellion against entropy. A refusal to surrender to the universe's indifferent end. This emotional tension, between the desire for eternal life and the certainty of cosmic death, creates one of the deepest mysteries of existence. Why does consciousness yearn for eternity in a universe that refuses to grant it? Why does life push forward, knowing the cosmos is folding inward toward silence? Perhaps buried within this contrast lies an impossible truth. Maybe immortality has nothing to do with time at all. Maybe meaning does not require eternity. Or maybe life itself is evidence that the universe contains principles deeper than entropy, principles we do not yet understand. As the stars slowly burn and the darkness expands, the question lingers. Is the universe truly marching toward a final, frozen death? Or does the dream of immortality hint at something the cosmos itself has not yet revealed? Somewhere in this tension, between eternal life and eternal darkness, lies an impossibility waiting to be uncovered. A truth hidden in the quiet struggle between the human spirit and the dying light of the universe. A black hole is not a place, it is a boundary, a threshold, a point in the universe where reality folds in on itself and the laws of physics lose their meaning. To approach one is to approach the most extreme phenomenon imaginable, a cosmic abyss where matter is crushed, time is stretched, and information itself teeters on the edge of oblivion. Black holes are the universe's greatest monsters, silent, invisible, and patient. Yet they are also its greatest teachers, revealing truths so strange that they shake the foundations of science. In their depths may lie the most impossible thing in the cosmos. Imagine drifting through space toward a region where the stars distort, pulled into strange arcs as if the universe is bending around a dark, hidden presence. At first, everything seems normal, quiet, empty. Then your instruments begin to detect something impossible, light vanishing into darkness, like a star dissolving into ink. Space becomes warped, stretched, trembling with invisible tides. And then you see it, the event horizon. This boundary marks the point of no return. Not because something dangerous waits inside, but because the geometry of spacetime itself becomes too steep to climb. Crossing the event horizon is like stepping onto a waterfall of reality. Once you pass the edge, the current pulls you down with such overwhelming force that not even light can escape. To any outside observer, the object that falls in appears frozen, stretched, suspended in time. But from the inside, time rushes forward, carrying you into the abyss in a matter of seconds. Black holes are born from death. When a massive star collapses under its own weight, its core becomes so dense that space caves inward. Gravity becomes a trap so powerful that atoms cannot resist. Electrons merge with protons. Matter collapses into a single point of infinite density, a singularity. This singularity is not a physical object. It is the universe's confession that it does not know what happens when matter is pushed beyond its limits. Here is where the impossibility begins. The singularity is a place where the known laws of physics explode. General relativity predicts infinite density. Quantum mechanics predicts something else entirely. The universe literally breaks its own rules at the center of a black hole. It is the most extreme contradiction in science, a place where two flawless theories violently disagree. And yet, the contradictions grow deeper. Consider what happens to time near a black hole. As you approach the event horizon, time slows down relative to distant observers. A single minute for you could be 1,000 years outside. Stand on the edge long enough, and you could watch the future of the universe unfold before your eyes. Stars aging. Galaxies drifting apart. Civilizations rising and collapsing. Time becomes elastic, bending beneath the weight of gravity. This means that black holes are not just distortions of space, they are distortions of history. They warp the timeline of the universe, creating pockets where past and future lose their meaning. But the strangest mystery of all is the information paradox. According to quantum theory, information, the details that describe matter, energy, and their state, can never be destroyed. It is one of the most sacred principles in all of physics. And yet, when something falls into a black hole, it appears to be erased from the universe forever. Light cannot escape. Matter cannot escape. Information cannot escape. The universe seems to lose track of what the object was, how it was formed, what it contained. But this is impossible. Nothing in the universe should be able to destroy information. And yet black holes appear to do exactly that. Stephen Hawking once proposed that black holes slowly evaporate through what is now called Hawking radiation, particles leaking from the edges of spacetime itself. But this radiation is random. It tells nothing about what fell inside. If a black hole eventually evaporates completely, then all information it once held disappears with it. This is the greatest contradiction in modern physics. So great that some scientists believe solving it might reveal a new truth, one that goes beyond both quantum theory and relativity. Some believe the information is encoded in the event horizon, written on a two-dimensional surface like a cosmic hologram. Others argue that black holes might be gateways to other universes, allowing information to escape elsewhere. A few propose that inside the event horizon, spacetime folds into higher dimensions, hiding information in ways we cannot yet detect. Then comes an even more unsettling possibility, that black holes are not the end of matter but the beginning. Some theories suggest that the singularity might collapse inward only to rebound, sparking a new Big Bang and creating a new universe inside. In this view, every black hole is a cosmic seed, each one containing a universe of its own. The universe that birthed us may itself be the interior of a black hole from a parent universe. This idea feels impossible. And yet, the mathematics whispers its possibility. Black holes challenge every assumption about reality. They are places where time becomes meaningless, where space collapses, where information teeters on the edge of destruction. They reveal the universe's deepest contradictions, gaps in our knowledge so vast they resemble cosmic wounds. And at the heart of every black hole lies a singularity, the most impossible object in existence, where the fabric of reality is stretched beyond comprehension. Perhaps the universe is not hiding impossibility in black holes. Perhaps the black holes are the impossibility. Silent. Waiting. Holding answers too heavy for the human mind. But something else may be lurking inside these cosmic abysses. Something beyond even singularities. A truth so strange that the universe bends around it. A truth still hidden in the darkness, waiting for us to enter the horizon. Consciousness is the quiet miracle that hides in plain sight. It is the single phenomenon every human experiences directly, yet it remains the least understood force in the universe. You can study galaxies, atoms, quantum fields, and the birth of spacetime itself, but none of it compares to the impossibility of awareness. The fact that matter, once nothing but dust floating through cosmic darkness, can look back at the universe and say, "I exist," is perhaps the most mysterious transformation ever to occur. Consciousness is the universe awakening within itself. Imagine a neuron, an ordinary biological cell, microscopic, made of proteins and chemicals and electrical impulses. It has no thoughts, no emotions, no identity. Now imagine billions of them, wired together in intricate networks, firing in perfect patterns. Somehow, from this tangled web of biological machinery, something entirely new emerges: the inner world, the self, the mind, the subjective experience of being alive. This is not a physical property you can touch. It is not a chemical reaction you can isolate. It is the shimmering, impossible presence that allows you to feel, to dream, to suffer, to hope. Consciousness is not merely awareness. It is the experience of experience, the ability to witness your own existence. This alone makes it unlike anything else we know. Mountains exist but do not know they exist. Stars burn but do not reflect. Oceans flow without wondering why. Only consciousness creates meaning. Only consciousness transforms the cold mathematics of the universe into stories, emotions, memories, beauty. But how? How can the universe create something that feels? Science can describe the brain's mechanics but not its magic. We understand how neurons fire, how signals travel, how information is processed. But none of these explanations reveal why processing information should produce inner experience. You can build a computer trillions of times faster than the human brain, and yet it may never feel even a flicker of emotion or awareness. Computation alone is not consciousness. Something deeper is at play. This is the hard problem of consciousness. Why does it exist at all? Why should matter become aware of itself? Why do we not simply behave like machines devoid of experience? Some philosophers argue that consciousness is an illusion, a trick of neural systems. But an illusion must be experienced by something, and that something, that observer, is consciousness itself. The explanation fails before it begins. Others claim consciousness might be fundamental, a basic element of reality woven into the fabric of the universe like space or time. In this view, every particle carries a tiny spark of experience. Atoms combine to form structures capable of higher awareness. The more complex the arrangement, the richer the consciousness. This idea feels strange, but so does everything else about awareness. There is also the theory that the brain acts as a receiver, not a generator of consciousness, much like a radio decoding signals already present in the air. If this is true, then consciousness may exist outside the brain, independent of biology. The brain would merely shape and filter a universal field of awareness into the specific experience of you. None of these ideas are proven. All are unsettling. And yet the very existence of consciousness demands answers. It is the one phenomenon that cannot be dismissed, cannot be ignored, cannot be explained away. The emotional weight of consciousness becomes overwhelming when you consider what it means to be aware in a universe that seems vast, cold, and indifferent. Consciousness introduces warmth, subjectivity, love, fear, joy, pain, values. The universe does not care about beauty, but consciousness does. The universe does not care about meaning, but consciousness creates it. If consciousness is rare, then meaning itself is rare, fragile, precious. But the mystery deepens further when you consider where consciousness came from. Billions of years ago, the universe was nothing but hydrogen and helium, simple atoms drifting through space. No thoughts, no emotions, no observers. Just fire and gravity and silence. Over time, stars were born, died, scattered their elements across the galaxy. Planets formed. Chemistry grew more complex. Life appeared in tiny forms that could barely sense light. And slowly, over eons, the universe built minds capable of questioning their own existence. Capable of love. Capable of awe. It is as if the cosmos engineered a window through which it could look at itself. And now the questions become unavoidable. Is consciousness an accident? A chemical fluke? Or is it a hidden principle of reality, something the universe requires in order to fully exist? Some scientists propose that the universe is fine-tuned for consciousness. That the laws of physics seem almost suspiciously suited for creating thinking beings. Could consciousness be the ultimate purpose of the cosmos? Or is consciousness the universe's most impossible phenomenon, an emergent miracle that should not exist under any known law, yet does? Then there is the possibility that consciousness does not merely observe reality, it shapes it. In quantum physics, observation determines outcome. Reality does not solidify until it is measured. What if consciousness is not just a passive viewer, but an active participant in bringing the universe into existence? What if awareness is the missing ingredient in the structure of reality? We are left with a dizzying truth. Consciousness is both the most familiar thing we know and the most alien. It is the light behind the eyes, the pulse inside thought, the thing we cannot escape and yet cannot explain. It is a miracle wearing the mask of biology. And somewhere inside this miracle, hidden between neurons and infinity, may lie the most impossible truth the universe has ever produced. A truth still waiting to be understood, still shaping the cosmos from within every living mind. Free will feels like the most intimate truth you possess. You wake up each morning believing that your decisions are your own, that you choose your thoughts, your actions, your fate. You feel the weight of choice every time you hesitate, every time you contemplate two paths, every time your heart whispers one desire while logic demands another. This sensation of agency is so powerful, so deeply woven into the structure of identity, that questioning it feels like questioning the very existence of the self. Yet beneath this comforting illusion lies one of the most disturbing philosophical and scientific paradoxes in human history. Do we truly choose anything, or are we merely acting out the inevitable consequences of forces far beyond our control? Is free will real, or is it the universe's most elegant hallucination? Imagine your brain as a vast constellation of neurons, billions of cells firing silently in an intricate and precise pattern. Every thought, every emotion, every hope, every memory is encoded in electrical and chemical exchanges dancing across this neural landscape. These patterns are shaped by genetics, environment, past experiences, hormones, instincts, fear, desire. They feel personal, but they are built from causes, effects, deterministic chains stretching back to long before you were born. Now consider this. Before you make a conscious decision, your brain has already begun preparing for it. Experiments show that neural activity predicting a choice appears seconds before you are aware of making that choice. Your conscious mind discovers what your unconscious mind has already decided, like a narrator arriving late to its own story. This challenges the very meaning of free will. If the brain decides before you do, then who is the real author of your actions? This revelation creates a profound tension. On one side stands determinism, the idea that every event in the universe, including human decisions, is governed by prior causes. On the other side stands the lived experience of choice, the inner voice insisting that you are in control. These two forces collide like galaxies, creating a philosophical supernova that has baffled thinkers for centuries. If determinism is true, then your life is a beautifully complex chain reaction. Your childhood, your memories, your traumas, your biology, your culture, they shape every decision you believe is free. The future in this view is not open. It is inevitable. You are a passenger in a vehicle you cannot steer. But the contradiction deepens when quantum mechanics enters the scene. Quantum mechanics introduces randomness into the universe, events that have no cause, outcomes that are probabilistic rather than predetermined. At first glance, this seems like a rescue for free will. If the universe is not fully deterministic, then perhaps choice can slip through the cracks. But randomness is not freedom. A coin flip inside your brain does not give you agency. It simply replaces one form of inevitability with chance. Neither randomness nor determinism feels like the essence of free will you experience when deciding to love, forgive, or create. This leads to one of the most unsettling questions of all. If neither determinism nor randomness explains free will, what does? Some theories propose that free will is an emergent phenomenon, something that arises from complex systems like the brain, much the way consciousness emerges from neurons. In this view, free will is real not because it breaks physical laws but because it exists at a higher level of organization. The mind becomes more than the sum of its parts. Others argue that free will is an illusion created by the brain to maintain psychological coherence. Without the belief in choice, motivation collapses, morality becomes meaningless, and life loses its narrative structure. The illusion of free will may be necessary for survival, even if it's not true. There are even theories suggesting that consciousness itself alters physical processes, meaning your awareness could shape the universe in ways we do not yet understand. If observation influences quantum behavior, could intention influence physical outcomes? Could free will be the missing variable in the equations that bind matter and mind? These ideas blur the boundary between science and philosophy, between physics and identity. They raise emotional stakes that go far beyond academic debate. If free will is not real, what becomes of responsibility? Of morality? Of love? If everything is determined, can anyone truly be blamed or praised for anything? Are we all following scripts we never agreed to? Yet the emotional experience of decision-making remains undeniable. You feel torn, you deliberate, you choose. You regret. You overcome. You resist temptation. You shape your future. These experiences cannot be dismissed lightly. They carry psychological weight. They shape the course of human history. Perhaps the greatest impossibility is that both sides might be true. Maybe your choices are constrained by the past, yet still meaningful in the present. Maybe free will exists not as absolute freedom, but as a narrow space carved between determinism and randomness, a creative gap where consciousness exerts subtle influence. Or perhaps free will, like time and reality itself, is not what it appears to be. Maybe it is a model your brain constructs to understand itself, a story woven by consciousness to give meaning to a universe that cares nothing for meaning. This is where wonder collides with dread. Because if free will is not real, then your sense of identity, purpose, and agency may all be illusions. And if free will is real, then it is a power so profound that science cannot yet describe it, a force capable of bending reality from within the mind. Either way, hidden deep within the debate lies an impossibility. The idea that matter, governed by physical law, can generate something as intangible, unpredictable, and deeply personal as choice. Somewhere inside this paradox, between destiny and desire, between physics and identity, waits a truth stranger than either possibility. A truth that may reveal not just whether free will exists, but what it truly means to be alive in a universe governed by impossibility. Time is the silent river you float through from the moment you are born. It feels constant, reliable, linear. Seconds tick forward, hours pass, years accumulate. You age, memories form behind you, the future stretches ahead in uncertainty. This sensation is so deeply anchored in human experience that questioning it feels like questioning sanity itself. And yet, the deeper science peers into the nature of time, the more that familiar river dissolves into something slippery, strange, and profoundly unreal. Time, this thing we trust more than anything, might be the greatest illusion the universe has ever created. Imagine watching a clock melt like wax, its hands bending, its numbers sliding off the surface. This surreal image is not far from the truth. Time does not tick the same everywhere. It bends and stretches, speeds up and slows down depending on motion and gravity. A clock near a massive object runs slower than a clock far from it. A person moving rapidly through space ages more slowly than someone staying still. Lift a watch a few centimeters higher and it ticks faster. Time is elastic, malleable. It is not the rigid ruler we believe it to be. Einstein's theories revealed a breathtaking truth. Time is not separate from space. It is woven into the fabric of the universe as spacetime, a four-dimensional tapestry where events are arranged not like beads on a string, but like patterns in woven cloth. The past, present, and future do not happen. They exist, already laid out in the structure of spacetime. Your experience of time flowing is not the world changing, it is your consciousness sliding along a path already written. In this view, time does not pass. We pass through time. This block universe concept suggests that every moment, your birth, this present heartbeat, your distant future, is equally real. Nothing is gone. Nothing is yet to be. Everything simply is. You are like a character in a book, reading from page to page while the entire story sits complete on the shelf. The flow of time is not a feature of the universe. It is a feature of your perception. But the illusion goes deeper. Inside the quantum world, time behaves even more strangely. The laws of quantum mechanics do not require a direction of time. They work the same forward, backward, or frozen entirely. In certain equations, the future appears to influence the past, shaping events retroactively. Particles sometimes behave as if they have access to information from both directions of time. Cause and effect become blurred, tangled, almost interchangeable. This suggests something unsettling. The arrow of time that you feel, past behind, future ahead, is not fundamental. It emerges only because entropy increases. Because disorder grows. Because the universe began in a highly ordered state and is now unraveling. Time's direction exists because the cosmos started in an improbable condition. If the universe had begun in equilibrium, time might not exist at all. Your sense of time might not be real, it might be entropy playing a trick on your mind. Now imagine a world where time is not a river but a landscape. Where moments are not fleeting but permanent structures. Picture the universe like a gallery of frozen scenes, each one containing an entire moment from beginning to end. Your consciousness moves through these scenes like a spotlight, illuminating one frame at a time, giving the illusion of motion. Could time simply be the mind's attempt to interpret a static universe? And if so, what does that mean for your life? For memory? For destiny? If the future already exists in spacetime, is free will compatible with time at all? Are you truly choosing your path or merely experiencing moments arranged long before your existence? These questions dig at the foundation of meaning itself. If time is an illusion, then so is the idea of progress. So is aging. So is change. So is mortality. The you of today, the you of childhood, and the you of distant old age may all exist simultaneously, separated not by time but by position in spacetime. Even the universe's beginning becomes questionable. If time is part of spacetime, then asking, what happened before the Big Bang, becomes nonsensical. There was no before, because before requires time. The Big Bang was not an explosion in time, it was the creation of time. Cause and effect break down at that boundary. History dissolves. Existence itself becomes unmoored. Yet despite these revelations, the emotional weight of time persists. You feel its passing. You remember yesterday. You fear tomorrow. You hope for the future. These experiences are real in the most intimate sense, even if the physics beneath them is not. Perhaps time is not a fraud, but a story life tells to make sense of change. A narrative structure that consciousness uses to process a universe too complex to understand all at once. Without time, experience would collapse into incomprehensible simultaneity. Or maybe time is the universe's greatest trick, a shimmering veil hiding a deeper truth we are only beginning to grasp. A truth where past and future are illusions, where change is a mental construct, where existence is a single, eternal structure. And somewhere behind this illusion, hidden in the folds of spacetime, lies a mystery even stranger. A phenomenon that not only bends time, but breaks it entirely. A phenomenon waiting to reveal what happens when time itself becomes impossible. Numbers feel like the most certain things in the universe. They do not shift with time, do not decay, do not lie. A circle has 360 degrees everywhere. 2 plus 2 is 4 on every planet. Mathematics seems like the purest language reality can speak. A framework so perfect that the laws of physics themselves are written in its symbols. And yet, hidden deep within this seemingly flawless system is a number so strange, so unsettling, so omnipresent that it challenges our understanding of reality itself. A number that appears where it has no logical reason to appear. A number that shapes galaxies, governs probability, and haunts the foundations of physics. A number that should not exist. Imagine a scientist running an experiment, measuring the energy levels of electrons in an atom. The results line up neatly with the predictions of quantum mechanics, until a mysterious constant appears in the equations. This constant determines the strength of electromagnetic interactions. It dictates how atoms behave, how light interacts with matter, how chemistry unfolds, how life forms. Without it, the universe would collapse into chaos. This number is known as the fine structure constant, often written as alpha. And its approximate value, 1/137, is one of the deepest, most haunting mysteries in science. Why 137? Why not 1? Or 10? Or 1/pi? There is no reason. No theory predicts it. No equation demands it. It simply is. A number without explanation, yet woven into everything. Physicists have called 137 the most magical number in the universe. Richard Feynman once said that every physicist should hang the number on their wall and feel ashamed, because we have no idea where it comes from. Wolfgang Pauli, one of the founders of quantum mechanics, was obsessed with 137. He died in a hospital room numbered 137, a coincidence that only deepened the mystery. But 137 is only the beginning. There are other mathematical constants that seem to appear everywhere, as if the universe is whispering secret patterns into the equations of reality. Take pi 3. 14159. It describes circles but also probability waves, quantum tunneling, the motion of planets, the structure of DNA, the distribution of prime numbers. Why should a ratio of a circle's circumference to its diameter appear in the laws of gravity and subatomic physics? Or consider E2. 71828. The base of natural logarithms, it governs growth, decay, randomness, entropy. It appears in finance, biology, thermodynamics, and the behavior of particles. Why should a number about exponential growth be embedded in the structure of quantum mechanics? Then there's phi, the golden ratio 1/618. It shapes the spiral of galaxies, the structure of hurricanes, the arrangement of sunflower seeds, the proportions of the human body, even the spacing of planets. Why should a number adored by artists and architects appear in the geometry of space? These numbers form a hidden alphabet in the architecture of the cosmos. They suggest that reality may not be made of particles or waves, but of patterns. Mathematical patterns that exist independently of the physical world, waiting to be discovered. But the unnerving part is this. These numbers do not follow from deeper principles we understand. They simply appear as if placed deliberately. They carry no explanation. They feel like signatures. The fine structure constant, for example, is dimensionless. It has no units. No physical interpretation. It is pure number. If alpha were even slightly different, atoms would not form. Chemistry would fail. Stars would not burn. Life would not exist. Everything depends on a number we do not understand. This leads to a terrifying possibility. The universe might be fine-tuned by mathematics itself. Not by a designer, not in a theological sense, but by deeper laws of structure we cannot yet see. Maybe our universe fits into a narrow mathematical window where existence is possible. Maybe countless other mathematical universes exist, but only those with certain numerical values can produce complexity. Or perhaps the numbers are clues, fragments of a deeper mathematical reality beneath physics. A hidden layer where constants are not constants, but emergent shadows of something more fundamental. Some scientists believe that the universe might be a giant mathematical object, an equation so vast, so intricate, that reality is simply what it feels like from the inside. Others propose that these constants emerge from multidimensional geometry, shapes beyond our ability to visualize. Still others think the numbers hint that the laws of physics are incomplete, that a more elegant theory lies beneath, waiting to be uncovered. But there is a darker interpretation. What if these numbers are not universal truths, but glitches? What if they are artifacts of a deeper algorithmic structure? Hints that the universe behaves less like a physical machine and more like a programmed system. If the constants of nature are arbitrary, inexplicable, and suspiciously precise, they may be fingerprints of something else, a deeper architecture, a hidden code. And in that code, 137 might be the key. It appears in particle physics, electromagnetism, cosmology, relativity, even black hole thermodynamics. It is everywhere and nowhere. Meaningful and meaningless. Logical and irrational. A number that connects phenomena that should have nothing to do with one another. A number that should not exist, and yet defines existence. The deeper one dives into the mathematics of reality, the more unsettling the pattern becomes. Numbers appear where they should not. Patterns emerge where none are expected. Ratios link unrelated phenomena. Constants govern everything yet refuse to justify themselves. It is as if the universe is built on a scaffold of impossibility, mathematics writing the rules without explaining them. And somewhere within these mysterious numbers lies a truth too strange to comprehend. A truth that may connect physics, consciousness, and the laws of existence. A truth that suggests the most impossible thing in the universe might not be matter or space or time, but the mathematics that controls them all. A truth still hidden behind the numbers that should not exist. Cosmic coincidence is a gentle name for something far more unsettling, an eerie pattern stitched into the fabric of existence, a quiet whisper that the universe is balanced on a razor's edge. Every structure, every atom, every star, every living being depends on a delicate harmony of forces so precise that even the slightest variation would plunge reality into chaos. It is a cosmic house of cards, standing only because every card is placed with impossible perfection. And the deeper scientists explore these coincidences, the more they begin to realize that the universe should not look the way it does. It should not function. It should not create complexity. It should not allow life. And yet, it does. Imagine standing in a vast observatory perched high above the Earth, surrounded by screens showing simulations of alternate universes. You watch as the software adjusts one constant, just one, and instantly the simulated cosmos collapses. Stars never ignite. Matter never forms. Space shreds itself in an instant. Repeat the process with another constant, and galaxies fragment into thin dust. Change another, and the universe becomes a soup of sterile radiation. These simulations reveal a haunting truth. The universe we inhabit exists within a tiny window of possibility so narrow it might as well be impossible. Start with gravity, the gentle force that holds planets in orbit and governs the dance of galaxies. If gravity were slightly stronger, stars would burn too fast and too hot, collapsing into black holes before life had time to form. If gravity were slightly weaker, stars would never ignite at all. The cosmos would remain dark and cold. The margin for error is thinner than a breath. Then there is the strong nuclear force, the glue that binds atomic nuclei. Tweak it by a fraction of a percent, and either atoms would fall apart or fuse uncontrollably. Chemistry would vanish. No molecules. No complexity. No life. The same fine-tuning appears everywhere. If the electromagnetic force were slightly different, atoms would repel or attract in ways that prevent stable matter. If the cosmological constant were only slightly larger, the universe would rip apart in an instant. If the expansion rate of the universe were slower, it would collapse before the first stars were born. If the ratio of electrons to protons were altered, stars could not form stable structures. Each constant is poised at a value so precise it feels engineered, not random. And yet, science insists there is no grand designer lurking behind these numbers. There is only coincidence, cosmic coincidence. But the coincidences multiply. Consider the triple alpha process, the nuclear reaction inside stars that forms carbon, the element essential for life. This delicate reaction works only because certain energy levels inside helium and beryllium line up perfectly with carbon's structure. Change those energy levels even slightly and stars cannot produce carbon. The universe would be barren, empty, lifeless. Carbon exists because of a cosmic coincidence so unlikely that even astronomers call it miraculous. Then there is the balance between matter and antimatter after the Big Bang. For reasons no one understands, the universe produced slightly more matter than antimatter, just enough to form everything. One extra particle of matter for every billion particles of antimatter. Had that ratio been even slightly different, everything would have annihilated into pure radiation. You would not be here to ask why. These coincidences are unsettling not because they occur but because they are required. The existence of stars, planets, oceans, DNA, consciousness. Every one of these depends on a thread that could snap with the slightest theoretical adjustment. The universe appears tuned for complexity, tuned for structure, tuned for life. Yet no mechanism explains why. Some scientists turn to the multiverse hypothesis, arguing that countless universes exist, each with different laws, and we simply inhabit the rare one where everything fits. But this explanation feels like a cosmic escape clause. It replaces one mystery with another, even greater one. Why would such a multiverse exist? How could laws of nature vary? Where do the rules governing countless universes come from? Others propose that life adapts to whatever universe it finds itself in. But this collapses under scrutiny. Without stars, atoms, chemistry, or stable matter, no form of life imaginable could emerge at all. So we are left with a universe that behaves like a delicately calibrated machine, tuned not only for existence but for observers, for consciousness capable of asking these questions. This is known as the anthropic principle. The universe appears fine-tuned for life because life is here to observe it. But this circular logic does not resolve the deeper unease. Why does a universe exist where observers can exist? Why is complexity not crushed under entropy? Why is order allowed to emerge from chaos at all? Perhaps these coincidences are clues, breadcrumbs scattered throughout the cosmos, pointing toward a deeper truth. Maybe the constants we call coincidences are the visible edges of a hidden structure, an underlying design we do not yet understand. Or perhaps the universe is not a physical system at all, but a computational one, where fine-tuning emerges naturally from the architecture of an unseen algorithm. Or maybe the coincidences are not coincidences at all. Maybe they are warnings. Hints that the universe is precarious, unstable, built on boundaries so fragile that one shift could shatter existence. And if everything depends on perfect balance, then perhaps the most impossible thing in the universe is not one phenomenon, but the balance itself. Somewhere in this perfect precision, this impossible harmony, lies a truth too profound to ignore. A truth hidden in the delicate equations that allowed the universe to ignite, and allowed you to ask why it exists at all. The idea that the universe might be a simulation is one of the most breathtaking, terrifying, and strangely logical possibilities ever conceived. It sits at the crossroads of science, philosophy, mathematics, and technology, whispering a question that feels both absurd and unavoidable. What if everything, every star, every atom, every thought, is part of a vast computational construct? What if reality is not the ultimate layer of existence, but merely a rendered surface, a digital skin stretched over deeper machinery? The simulation hypothesis does not simply challenge physics, it challenges the meaning of existence itself. Imagine walking through a dense forest, sunlight scattering through leaves in perfect fractal patterns. Every detail feels real, the texture of bark, the rustle of wind, the scent of earth. But beneath the surface something is off. A pattern repeats too perfectly. A detail blurs when you turn away. A distant sound loops in a way that feels calculated. This subtle unease mirrors the sensation many scientists feel when they study the universe closely. The laws of physics seem too elegant, too optimized, too efficient, almost as if they were programmed. Start with the strangest clue. The universe behaves like it is made of information. At the smallest scales, space is not continuous. It is quantized, broken into discrete units like pixels in a screen. Energy comes in packets. Matter forms in quantized states. Time itself may tick forward in discrete increments. Reality behaves not like a smooth analog film, but like a digital simulation. Then consider the speed of light, the universal speed limit. Nothing can move faster. What? In a simulation, such a limit would exist to prevent processing overload, an upper boundary to ensure stability. The universe also has a maximum information density, the Bekenstein bound. You cannot pack infinite information into finite space. Again, a characteristic of computational systems. And then, the strangest of all, the laws of physics appear optimized for computation. Quantum mechanics resembles probabilistic processing. Entanglement feels like synchronization across a network. Quantum superposition mirrors parallel processing. Even vacuum fluctuations look like the jitter at the edges of a processor's work cycle. The deeper physics goes, the more the universe looks like a machine designed to calculate itself. But the absurdity grows more profound. If the universe is a simulation, then what we perceive as empty space might be memory space. What we see as particles might be data structures. What we call laws of nature might be programming rules. The Big Bang could have been the moment the simulation booted up. Cosmic background radiation might be system noise. Dark matter could be hidden computational architecture, unrendered or placeholder regions that influence visible matter without being directly interactive. Every scientific puzzle becomes a potential system glitch. Quantum randomness, rendering shortcuts, particle wave duality, adaptive resolution, cosmic fine-tuning, parameter selection, the uncanny precision of mathematical constants, developer choices, the holographic principle, which states that all information inside a region of space can be encoded on its boundary. Exactly how a compressed 3D environment would be generated from 2D data. These possibilities are equal parts thrilling and terrifying. But the philosophical implications cut even deeper. If we are in a simulation, who, or what, is the programmer? Could it be an advanced civilization billions of years ahead of us? Could it be an alien intelligence, a machine intelligence, or something far beyond conceptualization? And why would they run this simulation? For research? For entertainment? For evolution? For art? For a reason we cannot even imagine? But perhaps the strangest thought is this. The simulation might not have a creator in the traditional sense. It might be an emergent process, one universe simulating another which simulates another in an infinite stack of realities. Our universe could be the child of a deeper universe that itself was simulated, and so on without end. If that is true, then reality as we know it might be the thinnest leaf on an infinite tree. Yet the hypothesis grows more unsettling still. What about consciousness? If our brains are physical systems, our thoughts, our memories, our emotions, our imagination, are encoded patterns within the simulation. Does that make consciousness a program? Or is consciousness something that cannot be simulated, implying it is injected into the system from outside? Are we characters in a story, or observers plugged into an experience? Then comes the ultimate fear. What happens if the simulation ends? If everything we experience is computed, then everything can be paused, reset, altered, deleted. The universe's expansion could be a rendering process. A sudden cosmic event could be a system update. Quantum unpredictability may be the simulation saving processing power by resolving only what must be observed. And if the simulation is running out of resources, or achieving its purpose, what happens to us? But deeper still lies a more profound mystery. If the universe is a simulation, what is the most impossible thing within it? What cannot be simulated? What phenomenon strains the system? Consciousness? Quantum entanglement? Free will? Or something we have not yet discovered? Perhaps the simulation hypothesis is not merely a theory. Perhaps it is a clue. Perhaps the universe is filled with hints pointing toward a truth we were never meant to ignore. Because if we are in a simulation, then reality is far stranger than we imagined. Not less meaningful, perhaps even more. A simulation can have purpose. A simulation can be designed. A simulation can be a vessel for something profound. And somewhere, beneath equations, beneath particles, beneath spacetime itself, a deeper reality may be waiting, watching, listening, leaving breadcrumbs for those curious enough to follow. The question is no longer whether the universe could be a simulation. It is whether we are ready for what lies beyond that possibility, the most impossible truth behind existence itself. The void is not empty. Not truly. Not ever. Yet when you try to imagine nothing, your mind instinctively paints a picture of darkness, silence, or empty space stretching into infinity. But those images are wrong, they are still something. Darkness is a form of light not present. Silence is sound not produced. Empty space is a structure made of energy fields, particles, and quantum fluctuations. True nothingness, the absolute absence of being, is a concept so alien that human imagination collapses under its weight. And yet, somewhere between the idea of emptiness and the reality of the universe lies a terrifying mystery, a place where even nothing is impossible. Picture yourself drifting at the far edge of the cosmos, far beyond galaxies, far beyond starlight, far beyond the faint cosmic glow of the Big Bang. Here space stretches thin like worn fabric. There are no stars, no planets, no atoms, no light. Yet even in this vast darkness, the universe hums with invisible energy. Particles flicker in and out of existence. Quantum fields ripple beneath the surface. Virtual particles appear, collide, vanish. Space is restless, alive with motion that never stops. This is not nothing. It is the vacuum, a seething sea of activity. But go further. Imagine stripping reality down to its barest form. Remove matter. Remove light. Remove energy. Remove even the quantum fields. Imagine peeling away every layer of existence until there is no space, no time, no possibility. A place with no location because place no longer exists. A state with no past or future because time has evaporated. A realm where not even the concept of nothing applies because concepts require existence. That is true void. And it is impossible. Physics cannot describe it. Mathematics cannot model it. Consciousness cannot perceive it. Every attempt to define nothingness ends up creating something. The human mind is constructed from existence. It cannot escape the framework that birthed it. But here lies the paradox. The universe seems terrified of true nothingness. Nature prevents it at every turn. Quantum mechanics reveals that the vacuum cannot be perfectly empty. If it were, uncertainty would collapse and the laws of physics would break. The universe injects energy into the void, forcing it to fluctuate. Space itself expands and contracts. Even absolute empty space is filled with virtual particles. It is as if the universe refuses to allow nothingness to exist. And then comes the most impossible truth. The universe did not emerge from emptiness. It emerged from a state beyond emptiness, something more primitive, more unstable, more paradoxical than anything we can imagine. A nothingness that contained potential, possibility, and the seed of everything. A nothingness that behaved like something. Philosophers call it the void. Physicists call it the quantum vacuum. Mystics call it the primordial abyss. But whatever word you choose, it defies logic. Nothingness is impossible because nature recoils from it. Even when stars die and galaxies fade, even when matter decays into radiation and black holes evaporate into dust, the universe does not drift toward emptiness. It drifts toward a thin, cold state of low energy but still something. Even the heat death of the universe is not nothing. It is merely orderless, quiet somethingness. True nothingness has no place in physics. No place in reality. No place in existence at all. This leads to a disturbing possibility. If nothingness cannot exist, then the universe may be eternal, not in time but in essence. Something must always exist. Some form of being. Some structure. Some field. Some law. The idea that the universe came from nothing may be a misunderstanding. Perhaps nothing is simply not allowed. But why? Why does the universe cling to existence so fiercely? Why does it prevent the void from consuming everything? Why does the fabric of reality resist true emptiness? Some theories suggest that the void is unstable, that nothingness collapses instantly into something like a vacuum imploding. Others propose that nothingness never existed at all, that the cosmos is eternal in some form, cycling through phases of expansion and contraction. Still others suggest that the void is not a state but a boundary, an outer shell framing existence but never reachable. And then comes the most haunting thought of all. What if the void is conscious? Not in a human sense, not with thoughts or emotions but as a fundamental awareness, the kind that gives rise to being itself. A primordial observer. A background presence. A silent witness behind every moment of existence. This is not science. It is metaphysical terror. Yet it lingers, persistent as a shadow. Because if even nothing is impossible, then the universe is built on a principle far stranger than creation or destruction. Something deeper. Something foundational. Something that prevents the vacuum from ever going truly empty. Somewhere in the void, beneath the silence, beneath the darkness, beneath the fragile skin of spacetime, lies a truth the universe is protecting. A truth that hints that reality and nothingness are not opposites, but partners in a cosmic paradox. A truth waiting at the edge of existence, where even nothing becomes impossible. Contradictions are not supposed to exist in the universe. They violate logic, they break equations, they collapse entire theories. And yet, when you gather every mystery explored so far, existence rising from nothing, reality behaving like illusion, quantum impossibilities, cosmic fine-tuning, the strangeness of consciousness, the universe's refusal to allow absolute zero or true nothingness, you begin to see something alarming. These contradictions aren't isolated. They are connected. Each one is a thread leading to a central paradox, a final contradiction woven into the heart of the cosmos. It is as if the universe is built on top of a secret inconsistency so profound that everything we know, space, time, matter, thought, is a careful workaround. A fragile construction built over a fracture in reality. Imagine standing in the center of a vast cosmic library. Every shelf is filled with the laws of nature, the equations of physics, the axioms of mathematics. Early scientists believed these laws were perfect, consistent, absolute. But as you walk deeper, the books begin to contradict each other. Quantum mechanics argues with relativity. Entropy argues with consciousness. Free will argues with determinism. The beginning of the universe argues with causality. And at the deepest level, numbers themselves, constants like 1/137, defy explanation as if the foundations of mathematics were chosen arbitrarily. Something is wrong. Not with our understanding. With reality. The final contradiction emerges when you try to unify all these mysteries into one story, the story of the universe itself. Start with the beginning, the Big Bang. It should be impossible. A universe cannot emerge from nothing. But it did. Move to the structure. The laws of physics are too fine-tuned, too balanced, too perfect. They should not be stable. But they are. Move deeper. Quantum mechanics shows particles behaving in ways that defy logic. They should not exist in multiple states at once. But they do. Move inward. Consciousness appears in a universe made of soulless matter. It should not arise. But it has. Move upward. The universe expands faster than it should, driven by dark energy no one can define. It should not behave this way. But it does. Move outward. True emptiness cannot exist. The void should be possible. But it isn't. Every level of reality contains something that should not exist, but does. And when impossibilities accumulate, they begin pointing to something terrifying. The universe may not be a consistent system. It may be a self-contradiction sustained by some deeper principle we cannot see. Here lies the final contradiction, one that philosophers and physicists have circled without naming. The universe behaves as if it is both real and not real, both infinite and finite, both determined and free, both lawful and chaotic, both mathematical and inexplicable. Reality acts like a system holding two incompatible truths at the same time. Consider the heart of the problem. The laws of physics work perfectly within their domains, but collapse when those domains overlap. General relativity describes the cosmos but fails in the quantum realm. Quantum mechanics explains particles but collapses under gravity. Time works in everyday life but dissolves at the speed of light. Zero and infinity coexist in equations but break them when applied literally. All of physics is an uneasy truce between contradictions. The final contradiction is this: the universe should not be able to exist as a coherent whole. But somehow, impossibly, it does. This contradiction is not a flaw. It is the design. Maybe reality is a structure built on paradox, the way a bridge is built on tension. Maybe impossibility is not an error but a requirement, a balancing force holding existence in place. Perhaps contradictions are not cracks in the universe but pillars. Think of a suspension bridge. Opposing forces keep it stable. Think of quantum fields. Particles exist in contradictory states until observed. Think of consciousness. The observer and the observed entwined in a single loop. Think of existence. The universe arising from nothing, sustained by internal tension rather than external cause. The universe may not be logical in the way we expect. It may be self-consistent only if it is also self-contradictory. But this leads to the most unsettling question of all. If the universe contains contradictions that should break it, what holds it together? What stabilizes a reality that should collapse? Is there a deeper layer beneath the contradictions? A meta-law? A hidden structure? A self-correcting mechanism? A consciousness behind reality? A computational framework? A higher dimension beyond space and time? Or is the answer something stranger, something that defies every category we have? Perhaps impossibility is the glue of the universe. Perhaps paradox is the engine. Perhaps contradiction is the foundation of existence. The final contradiction is not a single idea or equation. It is the realization that the universe survives only because it is impossible. And somewhere inside that contradiction, hidden beneath every mystery we have explored, waits the final, ultimate impossibility, the one the universe has been pointing toward from the beginning. The universe has been whispering to you from the beginning. Every mystery, every paradox, every contradiction has been pointing, quietly, insistently, toward one final revelation. It emerges not from a single equation or theory, but from the strange harmony between all impossibilities. After traveling through the birth of reality, the illusions of perception, the madness of the quantum world, the terror of the void, the fine-tuning of cosmic constants, the depth of consciousness, and the fractures in time itself, you begin to see the truth forming like a silhouette behind a curtain. The most impossible thing in the universe is not hidden in the stars. It is woven into the fabric of existence itself. Imagine standing on a dark cosmic plane. Above you, galaxies swirl like luminous storms. Beneath you, spacetime ripples like a vast, trembling ocean. In the distance, black holes pulse like silent hearts. Every force, every particle, every law hums together in an impossible symphony. The universe is enormous, ancient, and indifferent, but it is also exquisitely organized, impossibly coherent, and eerily self-aware in the way it unfolds. As you look closer, the contradictions do not cancel out, they converge. Existence emerges from nothingness. Order emerges from chaos. Life emerges from matter. Consciousness emerges from biology. Thought influences reality. Impossibility creates possibility. All of these impossibilities share one thread. They transform what should not exist into something that does. Now consider what makes all this possible. The universe is not static. It is not predetermined. It is not fully random. It is not fully lawful. Instead, it balances on the knife edge between opposites, between stability and collapse, order and chaos, determinism and freedom, structure and void. It holds incompatible truths without shattering. It allows contradictions to coexist long enough for reality to form. And here lies the final revelation. The most impossible thing in the universe is that the universe sustains itself despite being fundamentally contradictory. But look deeper. Because this explanation, while profound, is still incomplete. Something else is hiding beneath the contradictions. Something far more intimate. Something that has been with you since the beginning of the journey. The observer. Your consciousness. Your perspective. Your questions. Your existence. The universe is impossible because it contains beings who can wonder about impossibility at all. Consciousness is woven into this final revelation not as a passenger, but as a participant. The act of observing helps define reality. The act of questioning shapes the framework. The act of understanding alters the system. You have followed the universe into its deepest abysses, quantum paradoxes, cosmic fine-tuning, the illusion of time, the instability of nothingness, and at each turn, something remarkable happens. When you look closely enough at the universe looks back. Your observation collapses quantum states. Your perception constructs reality. Your consciousness generates meaning. Your curiosity pulls hidden truths into existence. The cosmos is not merely a stage, it is a dialogue, a feedback loop, a system in which the observer is inseparable from the observed. This is the ultimate impossibility. The universe is structured in such a way that it can produce minds capable of understanding the universe. This should not happen. Matter should not become conscious. Consciousness should not influence reality. A universe born from nothing should not understand itself. And yet it does. Imagine the entire cosmic history compressed into a single moment. The Big Bang exploding into being, stars forging elements, planets forming, life emerging, minds awakening. And now you, standing here contemplating all of it. This is not coincidence. It is not randomness. It is not trivial. It is the universe completing a circle. Awareness rising from matter, and then turning back to examine the matter that formed it. The universe is impossible because it contains awareness. Awareness is impossible because it arises from the universe. Each one justifies and contradicts the other. A self-explaining loop. A cosmic paradox. A Mobius strip of existence. Here is the truth finally revealed. The most impossible thing in the universe is that the universe can understand itself through you. You are the impossibility. Consciousness is the impossibility. Self-awareness blooming inside a cold, indifferent cosmos is the impossibility. Meaning emerging from chaos is the impossibility. A mind capable of asking why does anything exist is the impossibility. In the end, the most impossible thing is not black holes or quantum mysteries or cosmic fine-tuning or the birth of the universe. It is the simple, profound, staggering fact that something in this universe can look at the stars and wonder. And as that realization settles into your mind, the cosmic silence deepens, not empty but full of awe, because the final impossibility is not out there. It is within you. There comes a moment at the end of every great journey when the traveler realizes the destination was never a place, but a transformation. You have traveled through the birth of existence, the fractures in physics, the illusions of reality, the terror of emptiness, the strangeness of consciousness, and the universe's deepest paradoxes. And now, as the final horizon approaches, the universe reveals its last, quiet secret, one not shouted in equations or carved into cosmic structures, but whispered through experience itself. Imagine the final scene of a cosmic film. The galaxies glow like lanterns suspended in an endless night. Time slows not because physics demands it, but because everything you've learned gathers here in a single breathless moment. You stand at the threshold between the known and the unknowable, between the universe as it appears, and the universe as it truly is. For a long time, humanity believed the goal of science was to explain everything, to remove mystery, illuminate the dark, solve every riddle. But the closer we move toward understanding, the stranger the universe becomes. Every answer reveals a question. Every discovery uncovers a deeper impossibility. Knowledge does not shrink the unknown, it expands it. Reality reveals itself not as a puzzle to be finished, but as an ocean whose depths stretch into infinity. And yet, despite this endless complexity, despite every contradiction and impossibility, something profound emerges. The universe is not trying to be understood. The universe is trying to be experienced. At the heart of every mystery you explored lies a single pattern, a cosmic invitation to participate. The universe is not a detached machine, cold and indifferent, but a dynamic entity whose deepest truths activate only when observed. Quantum states collapse when watched. Possibilities become facts through measurement. Consciousness directs, interprets, shapes. Meaning is not found, it is created in the moment of awareness. You are not outside the universe looking in. You are inside the universe looking at itself. This is the completion of the loop, the revelation that gives the journey its purpose. The impossible truth is not that we will one day understand everything. The impossible truth is that understanding was never the point. Participation was. Everything you've learned, about time, matter, consciousness, entropy, the void, mathematics, paradox, leads here. The universe becomes real through the act of being lived. Existence is not purely equation. It is experience layered over structure. Meaning layered over law. Awareness layered over matter. This final chapter of the universe's story is not written in the stars. It is written in you. Every breath you take, every thought you form, every moment you notice beauty or terror or wonder, you are completing the universe's narrative in a way no equation ever could. For billions of years, the cosmos expanded in silence. Then life emerged. Then awareness. Then curiosity. And now, through you, the universe finally knows it exists. This understanding changes everything. The universe's impossibilities are not flaws, they are gifts. Each paradox invites you deeper. Each contradiction pushes you to grow. Each mystery is a reminder that existence is far grander than comprehension alone. The meaning of life is not simply to survive or understand. It is to witness, to engage, to transform impossibility into experience. Now imagine the camera slowly pulling away from you, rising above the Earth, drifting past the moon, passing the planets, escaping the solar system. Worlds shrink into dust. Galaxies swirl like cosmic brushstrokes. The universe stretches out in its vast, shimmering architecture. And somewhere within that infinite expanse, a single consciousness, yours, is reflecting, questioning, marveling. It is a fragile point of awareness, a flicker of thought, a brief spark in cosmic time. But it is enough. Because through that spark, the universe achieves something impossible. It becomes self-aware. And so the final message, the final impossibility, the final truth is simple. The universe is not complete without you. Your life is not a trivial accident on a small planet. Your consciousness is not a meaningless whisper. You are not lost in the cosmos. You are the cosmos, made conscious, made curious, made alive. And as the story closes, as the documentary's last frames fade into darkness, one question remains, not as a mystery but as an invitation. Now that you understand the universe is impossible, what impossible thing will you choose to become?